So what is Foundation Services? That's what we're going to be covering in this short video. If you've used any of the IoT solutions from MCU8 or 16, these are actually based on Foundation Services. Here we can see the AVR IoT WG development board based on a Mega 4809, and here we have the PIC IoT WG development board based on the PIC 24. So any of the solutions which you'll find in MCC or START for these two platforms are actually based on the Foundation Services framework. So at the top here we have independent software libraries which are used together to build an application framework. At the bottom we have hardware peripherals on a specific microcontroller. In the middle, Foundation Services or Foundation drivers provide an interface for the software libraries to run on any of the supported microcontrollers in MCC. The 8 and 16-bit PICs as well as AVR, and also there's a version which supports AVR in Atmel Start. So Foundation Services is a collection of software components that work together, including software applications in the form of examples, software libraries, and Foundation drivers. So the benefits of Foundation Services is that they provide a common set of software interfaces across different devices. This can make it easier to start an application on one device, then realize you need a feature on another, and easily move the application that you've developed so far. For example, have a look at the video how to implement I2C on PIC and AVR. In this video, Patrick demonstrates how to talk to a I2C slave, and after getting the application working on a PIC, he'll move it to an AVR. It gives you a small code size, and the ease of use of Foundation Services will be demonstrated in some of the videos in this series. So here are the Foundation drivers. Each will have a tooltip giving a clear description of what the component is. Here we can see the timeout driver hardware abstraction layer supporting a function scheduler and stopwatch functionality, and then we can click to open the documentation. So when we open the documentation, we get an overview of the different modes of the driver, as well as a functional description, so that we can understand certain aspects of how the driver was implemented. So for any of the Foundation drivers, you can select the specific instance of the hardware peripheral that you'd like to run it on. As the driver is added, this will be added with the default instance of the peripheral driver, but as you can see, this can be changed. One of the key ways that the ease of use has been improved is to include a number of use case examples or code snippets. So these example snippets are a major focus of the videos that we have on the timeout driver. You'll see that we start with the periodic timer mode, the simplest mode with repeating timer, and we demonstrate here the two ways that you can use the code snippets, either calling the function from main, where you'll have to add some header file includes, or cutting and pasting into main, and from there verifying the functionality, which would be the recommended method. Both of these are demonstrated in the first video. In the second, we continue and look at the one-shot timer, here triggering the timer to start on a button press interrupt, and then we will look at sending a payload to the timeout driver, and here using that payload to trigger only a certain number of timeouts. Let's get going with the periodic timer in the next video.